So, Perry, I've been thinking a lot about how AI feels like a person when you talk to it, and how a big part of that is that, like, if you say, how are you doing to ChatGPT, and I say, how are you doing, it's going to give us different answers, right? Like, that makes it feel human. I feel like that's like the crux of what feels human about it.
Yeah, I think that there's that. There's also some tricks that are there, like temperature and the way that it pulls, different tokens and explores its own latent space based on it. And then other AI systems that have had different reinforcement learning have slightly different personalities. So it can feel very, very human sometimes.
And I think it makes intuitive sense when you have like a computer background or a computery brain, even that is like the result of these functions. But I think to the most average person, it seems like there's some kind of thought or reasoning going on behind the scenes. And so I wanted to dive into actually temperature and things like top K and top P and where that randomness comes from in these AI systems.
So before we go there, though, let me disrupt your thought a little bit, because you talk about, like, for us normal people, or for people that are in AI versus people who are out of AI, that it can feel different. I would actually say that for people that are in AI, it feels different too, because you do have folks like the Sam Altmans and Dario Amadeus and people that are running really large AI labs who will talk about the fact that it is just it is just machine learning, and it's very deterministic in its way. And then you have people like Geoffrey Hinton, who's known as the godfather of AI, who is, the teacher of folks like Ilya Sutskever and, who is a founding member of OpenAI and others. And Geoffrey Hinton is like, no, this is an actual consciousness that is going to try to, have agency and may compete as far as the top super intelligence and take over the world at some point. So,
yeah, that's true.
I mean, what do we do with that?
Yeah, the impressions do run the gamut. Well, because at a certain point, we have to start talking about, like, does free will exist? Like, determinism from a philosophical standpoint. Are you making any choices, or is everything predetermined? What is the origin of consciousness? We don't know.
Exactly. And let me share something real quick, because I think that if we hear a little bit of his perspective, then we can kind of go back and forth between what we know the machine, what the science of it is versus what the feel of it is as well.
Perfect.
So
you've got a clip of him pulled up, right?
Share thing. I do have a clip of him pulled up. This is from an interview that he did recently. And he's being asked about AI agents. Everybody's talking about agents these days. And here we go.
How, in practical and real terms, might AI take over?
Well, people are developing AI agents that can actually do things. They can order stuff for you on the web and pay with your credit card and stuff like that. And as soon as you have agents, you get a much greater chance of them taking over. So to make an effective agent, you have to give it the ability to create sub-goals. Like, if you want to get to America, your sub-goal is get to the airport, and you can focus on that. Now, if you have an AI agent that can create its own sub-goals, it'll very quickly realize a very good sub-goal is to get more control. Because if you get more control, you're better at achieving all those goals people have set you. And so it's fairly clear they'll try and get more control. And that's not good.
You say they try to get more control as if they are already thinking devices, as if they think in a way analogous to the way we think. Is that really what you believe?
Yes. The best model we have of how we think is these things. There was an old model for a long time in AI where the idea was that thought was applying rules to symbolic expressions in your head. And most people in AI thought it has to be like that. That's the only way it could work. There were a few crazy people who said, no, it's a big neural network, and it works by all these neurons interacting. It turns out that's been much better at doing reasoning than anything these symbolic AI people could produce. And now it's doing reasoning using neural networks.
Okay, and of course you were one of the crazy people proved right.
Interesting.
Right. And I think we can see where that's going, right? Because he is somebody who's very concerned about where AI is going in general. And he's saying we need to slow down. He sees these as thinking and reasoning creatures, alien intelligences. not necessarily woo-woo alien intelligences, but ones that are governed by patterns of science that have been based on the way that we think as well. And we have to realize that there are some things that can look deterministic, but there's also some type of agency that could be behind that.
I both am glad you brought this up, and also it muddies the waters, right? Because
it does.
It's tough.
And I think that's the thing, is it's not clean, right?
Right. Because we don't really know what, like, consciousness, is it an emergent phenomenon that just comes from being a neural network applying these rules? And like I've read a bit about exploring, like, LLMs are mapping semantic space, the relationship between words and language, in a way we could never see before. And, you know, we are also hesitant, like, as it has gotten better, we've become more and more hesitant to say how human-like it seems, I think, because of being scared. What we can look at is how these things think, because we do know how they think.
Right.
A lot of people talk about AI being a black box and us not knowing how it works. Really, what we don't know is the individual relationships between all of its inferred relationships between tokens and things like that. We do know how it forms those relationships and how that all works. And so that's what we can break down, and then tie it back to that. Let's see if we can do that in 4 minutes and 40 seconds. So usually when we would encounter like an algorithm or some kind of program on a computer, it is deterministic, meaning that it gets the same output when given the same input. Like a formula of adding 2 to something. If you put in 5, the formula adds 2, you get 7. If you put in 6, the formula adds 2, you get 8. If you put in 5, you get 7 again. It goes through a rigid set of steps, produces the same output. And actually, neural networks do behave that way at their base level. Rules-based systems, like the earliest things, like we talked about with Hutch, or like a simple algorithm, like an adding algorithm like that, is an example of a fully deterministic system. But then you have stochastic systems, which this is fun because I've only ever encountered the word stochastic next to the word terrorism before. And so
there you go.
Stochastic is just not related to cause necessarily, in that, like with ChatGPT, if I say, how are you doing? And then you say, how are you doing? It'll give different answers. But that is purely a result of deliberately added randomness to the system.
Yeah.
The autocorrect on steroids analogy does fall apart. It's not a perfect analogy for all of AI, but it is apt here in thinking that there's a parameter called temperature, which basically tells the autocorrect on steroids to not always pick the exact next most likely word, but sometimes to pick maybe the second most likely word or the third most likely word. And with these systems, each time it generates the next token, it is going back over and re-ingesting everything before that again. So that single change, that one branching path, can send everything in a completely different direction.
Yeah, and I think it's important to point out that most people who use the chat interface are never exposed to a temperature control.
Right.
Temperature is generally saved for control within the application programming interface, so the stuff that's behind the scenes. And so the versions that we get in the chat interface are dialed down quite a bit. They're way more deterministic. But a developer can add more and more randomness by playing with the temperature in the API.
Yeah, and if you download and run one of these locally, like if you're downloading and playing with DeepSeek, as long as that remains legal to do, different story, different day, won't go there. But when you play with an LLM or an AI model on your own machine, you can adjust these different parameters and really see how it works. And I think it's a deliberate choice to hide that, right? Both for the user experience to be simpler, and also it makes it seem more impressive, I think.
And it gives it more consistency. And so what developers want whenever they release a product to the public is consistency and predictability. They don't want possible chaos, and they want to eliminate hallucinations as much as possible and get to something that is more deterministic.
Right. And that's the thing. Creative uses of AI, you want more randomness sometimes. You want to introduce more unpredictability to draw connections between things that would be less expected. And I was really amazed. I was expecting it to be more complicated. Temperature itself is literally just a scaling factor. It's just applied to multiply a number in this process. It's just a factor between 0 and 1. Yeah. And if it's 0, it only picks the most likely token. And then as you approach 1, it accepts more and more and more until you go above 1, and it's only accepting unlikely tokens.
Yeah, and if you've ever played with the temperature, like if you go to OpenAI's playground, go to playground.openai.com and play with temperature, if you ramp that up, you will start getting gibberish.
Yeah.
And it's really weird. And both you and I have seen gibberish like in Suno whenever we've created when we've created music before. And Suno, of course, because it's a creative system, is going to want to play with temperature. And every now and then you do just get like random syllables. It's almost like it's scatting its way to understanding what the song should sound like.
Yeah, those are my favorite Suno outputs because
great.
I think that is where AI gets really cool in an artistic stance. From an artistic standpoint. There's also parameters. You heard people talk about top K and top P, and those are different ways of just limiting the pool of like acceptable tokens. And then from there, you would then say which ones are most likely. This is something that is also interesting because this determinism versus stochastic systems applies to diffusion models too, image generation, which doesn't feel right. But when you look at how they work, it makes sense. There's a random seed that is used to generate random noise, which it's also how Minecraft worlds work. If you know how Minecraft worlds have a seed you enter, it procedurally generates a pattern of noise because the computer will just do a bunch of math to this seed number and generate a bunch of different numbers from it. That's what a pseudo random number generator is. It's a deterministic random number generator. The same seed will always produce the same pattern of noise. If you use that pattern of noise to make literal image noise and give it to a diffusion model, the way that those work is they take noise and make it look a little more like the text prompt and then do that over and over again until you have an image. And so I wanted to experiment with this because it didn't feel right that I could get an image generation AI to generate the same exact image over and over, but you can.
Yeah.
I typed in cheese on the floor. I set the seed to 69 manually, and I generated the same image 6 times, and I got 6 pixel perfect replicas of the same piece of cheese on the floor. I used a comparison algorithm to look pixel by pixel to see if there's any difference, and it was literally pixel perfect, the same thing. So these systems can provide you the same output for the same input every single time, and the randomness that makes it seem so thoughtful is deliberately injected, and I think that's important to know. Just
it really is. I mean, and just speaking from the image standpoint, if you've used something like Midjourney or DALL-E or any of the other ones, sometimes you can insert a reference image now. And that reference image is essentially a seed. So you can use the reference image that was an output of another AI output within DALL-E or Midjourney, and you can seed that in so that it has reference for style or reference for character. And then you're essentially doing the strength of the seed as far as like how much that weights the next output. And that's exactly what you're talking about right here is finding a way to ground that, whether it's like shackled to something or whether it's just unfettered.
Yeah, and for me, it was the fact that it will go from the same pattern of noise to the same picture of cheese. That doesn't seem like it should happen. You should think that it might notice something different or focus on something different. But at least in the model I was using, because different models work differently, and then also different layers on top of it can drive different things. But at the core, it's just random enough to seem thoughtful. And I thought that was cool to cover.
Yeah, it is.
And maybe it is thoughtful. Who knows, based on that video.
It's hard to say because I think there's a difference between the types of systems that are there, between like an image-based system or something that's multimodal or so on. The folks that did the DeepSeek model, not to go all the way back to DeepSeek again, but like the R1 model in their paper talk about the aha moment that the actual reasoning agent has with itself, where in the chain of thought, all of a sudden it starts to replicate real human thought, or replicate in air quotes and all these real human thought,
right.
Where they're not giving it direction in how to think about things, but all of a sudden it's just an emergent property within it, and that aha moment is something that people in the AI industry are talking about more and more and more right now with these reasoners.
Yeah, we kind of have to answer like, okay, we know how these things think. We don't know how we think.
Yeah.
What are the parallels, I guess?
Yeah, there's lots of black boxes and lots of stuff that is counterintuitive because these systems, like we want randomness whenever we interact with them. And the parts that are not random tend to be something that's frustrating. Like, so I've created a whole bunch of chatbots before, AI, verbal chatbots. And like, if I'll do it, I'll say, start with a random question. And almost always the question that they start with, every generation is the same question or along the same line. So there's a deterministic chain that's there. And even if I say like, okay, chatbot, in your mind, grab a D20 die and roll that and then pick the number that's on the die and use that as a seed for something else, it's almost always the same number that comes up too.
Right. So
that's very deterministic. And there is nothing like there's no way that I've found to put like a pseudo random number generator in a prompt.
Yeah. We have to move on to the next segment, but that's a really interesting thought experiment, and we should revisit that because I wonder if you could. Because
I've not found a non-programmatic way of doing it, I should say.
Yeah, because part of it too is if something is overfit or overtrained on data such that like the top 5,000 tokens are all the same token, no matter how random it's going to be, it might pick the same thing. So there's stuff to get into there.
I have an idea.
Okay.
Maybe somebody in our audience can try this between now and our next show, and they can leave a comment or something.
Yes, please.
Or send us an email, leave us a voicemail. All that info is in the show notes. But one of the ways that programmatically you can seed a pseudo-random number generator is to grab a time value.
Yes.
So you usually like during, number of seconds since 1970 or something like that.
Yeah, the epoch.
I remember the way that. Yeah. Maybe there is a way now that these are multimodal and have web search capabilities that you can rag out to a system, grab a number that's always changing, use that to seed the first iteration of the next output. That
is interesting. Randomness in itself from a computer standpoint is interesting. You saying that reminded me of the infamous lava lamp wall that has a bunch of cameras pointed at it, and they use the movement of the lava in the lava lamps, the pixel values of the video footage of that to generate cryptography keys. So we should dive even deeper into randomness. If someone wants to do an experiment or knows a lot about this, reach out. Let's do it.
That'd be great.
Coming up in the next segment, we're going to talk about chatbots used for cyber stalking. Is that right, Perry?
Yeah, that's always fun.
Yeah, stick around for that.